In Interstellar, the Earth is dying. Because of this, agriculture cannot be supported anymore. This in return will kill the human race. Because of this, NASA and the government organizations create an operation to find a new planet that all humans can live on. Cooper, the main character, finds out about this through receiving coordinates in an encoded message. He learns that Dr. Brandt is creating an equation to help lower the gravitational force on Earth, almost getting rid of it, so spaceships can go to a new planet without rocket fuel. NASA learns that in another universe far away from the Milky Way, there is potential to find a new planet where humans can migrate to. Cooper and his crew set out to find this planet. However, the universe is millions of light years away. Luckily, a wormhole is discovered next to Saturn that could send them to the universe faster than the speed of light. Think of a wormhole like a slide. You enter through one side and exit through the other. In space, it's a tunnel between two distant points in our universes that cuts through space-time from one point to another, making an instant transition faster than the speed of light. In this case, the wormhole entrance is from our universe into the other universe. Once making it through the wormhole, they learn that all the planets orbit a black hole called Gargantua. They make their way to Miller's planet, which is completely water. However, they experience time dilation, which is the slowing of time perceived by one observer compared to another. Since the black hole has such a strong gravitational field, it warps and curves time. The greater gravitational field there is, the more time dilation there will be. This is seen since 1 hour on Earth is 60 minutes and 1 hour on Miller's planet is 7 years. Taking a look at this diagram, we can see how a black hole curves space-time. Imagine a trampoline with a heavy rock in the middle. It will cause a curve in the center of the trampoline. Then imagine a small ball put on the edge of the trampoline. This represents planets that would orbit the black hole. Due to the gravity of the mass of the black hole, the ball will go towards the middle. This is what is happening when a black hole warps space-time and pulls things towards it and affects all measurements of time and space near it. This other diagram compares how the space-time is warped with a black hole compared to the sun. We can see that the black holes have way more mass and it has a stronger gravitational field. After Cooper enters the black hole, we see the fifth dimension. Taking a look at our own three dimensions, we know it's actually four dimensions, with one of the dimensions being time and the other three being length, width, and height. Our eyes perceive 2D shapes in our 3D world. The shadows we see are also 2D. The fifth dimension in the black hole is actually four dimensions, plus the dimension of time, making it five dimensions. In this fourth dimension, we would see 3D shapes. This tesseract is an example. Shadows would also somehow be 3D. However, our eyes cannot perceive this type of dimension. That's why in the movie, Cooper was allowed to view the fifth dimension in a way his eyes could perceive due to outside forces helping him. Time can also be controlled in this fifth dimension, which doesn't happen in our dimension. Time only goes forward in our dimension, but in the fifth dimension, it can be replayed. As seen down here, you can see the comparison, and thank you for listening.